All right. Hello, Sahit.
Wait, wasn't the title of your last video like bad teacher or something?
Worst teacher ever. That's what I call myself now.
Yeah, well, why did you put that?
No, it is because I always think that no, there's a better teacher than me. Okay. So I don't want to brag about me being the best teacher. I want to rather say negative things about myself. Say, okay, I'm not a great teacher. If my kids feel that I'm a good teacher, then my job is done. It's not about what I claim, right? It's about what you guys feel, how useful you find the class, how much you learn from the class, how much fun you are having in the class, right? So that's why I'm leaving that to the discretion of the kids in the class rather than me bragging about it. I will always keep claiming that I'm the worst teacher. Let's see what my kids say. Yeah? All right. So we have Dev, Jenna, Neil, then Yasmita, Ritika, Sahit, Samriddhi, Sarah, Saranya, and Vivan. Some more kids are still missing. Here in the classroom we have Tony. Praneeth would be joining us soon. So let's get started. So today's class, okay, is going to be more around breaking down what is a quadratic equation and how do we plot that. Meaning, when you have a quadratic equation, when you plot it on a graph paper, it draws what? What shape? Any idea? Hey, Praneeth.
A U-shape?
I'm sorry, Yasmita?
A U-shape?
A U shape. What is that? What is that called? Parabola.
Oh, parabola, yeah.
Yeah. So if I have, so today in today's class, right, our main focus is going to be on looking at a quadratic equation, plotting that on a graph paper, understanding what happens, what are the different properties of a parabola, which some of you would be already knowing. It will be more of a recap, going through it again, and then what are the different properties of parabola that we need to be aware of. And if I keep playing around with the equation, the quadratic equation, what happens to the parabola? I mean, which way it transforms. Okay. So, first thing first, the most basic, and now coming back to Jenna's point, right? Why I'm claiming myself to be as the worst teacher. I mean, that's why I'm portraying myself. I'm saying that I'm the worst teacher. Let's see if my kids say otherwise. Okay. If you guys feel otherwise, my job is done. I'm happy. I will not keep bragging about me being the best teacher because I don't really think that I'm the best teacher. I'm just a decent teacher who knows some things, who is teaching you guys something. Okay, so coming back to somebody joined, and that is who? Okay, Vishal joined in between. So some kids are still missing. Arush and Davik are missing. Sahit, would you know if they are joining? Or we will see. Saranya also joined. I'm sorry, beta?
I think they're joining late.
Oh, okay. Alright. So we're starting with a quadratic equation. Let's say y equal to x squared plus 2x minus 3. Okay? I have put an equation which I am calling as a quadratic equation. Why? Because the maximum power to one of the variable is 2. X is one of the variable where the maximum power is 2. This one has 1, but I'm still counting the maximum power, which is 2. So I'm calling this a quadratic equation. Yeah? Even if I put y equal to x squared, that is also a quadratic equation because maximum power to the variable is 2. Yeah? Let me start with the simplest form of a quadratic equation, y equal to x squared. Okay? And as I have been, or as I have told many of you in the previous classes, I don't really care about what kind of equation I'm dealing with. For me, every equation is just a contract between the variables. Now here's the contract, the deal between x and y. What is the agreement that we have between x and y is that square of x is equal to y. That's the agreement that we have between x and y. Okay. Any equation, if you say x plus y equal to 5, this is the agreement between x and y, which says value of x and value of y, if you add them together, you will get a 5. If x is 1, y is 4. That's how you're getting 5. If x is 2, y is 3. That's how you're getting 5. If x is minus 1, y is 6. That is how you're getting 5. That's the agreement between the variables. So when I'm looking at a quadratic equation, there also I don't discriminate. For me, every equation, be it a linear equation, be it a quadratic equation, or be it an equation which has x to the power 8 minus 6x squared. For me, this equation are the same conceptually, because there is an agreement between these two variables to get this outcome. Here, this is the relationship between x and y. Okay, this is the relationship between x and y. This is a contract. So, regardless of what type of equation we are dealing with, it's ultimately a relationship between the variables to get some certain outcome. Yeah. So now, going back to the quadratic equation, y equal to x squared, simplest form. I am calling it a quadratic equation because the maximum power to the one of the variable is 2. Yeah. So far it's okay. I have repeated myself so many times, not to annoy you guys, but to make sure that we are on the same page. Everybody is on the same page so far? Now, so this is y equal to x squared. This is one quadratic equation. This is the agreement or relationship between these two variables. Okay. And I am very happy to share one important fact today. One of my students, probably the first student in the class, that is Tony, who came to the class driving by herself. So far, none of the students have come by driving by themselves. That means none of my students have got the driving license and have that, what do you call, that ability to drive by herself. So she is the first self-sufficient student in the class now. And I hope you guys get your driving license also in a legal way, in a timely manner, so that you can drive by yourself also and become more self-dependent. So coming back to this one, that was just a information to share. So this is the agreement that we have. So let's look at that. Let's break down this agreement. X and y. This is the agreement we have as part of this equation, which says x squared is equal to y. Meaning, if I put x equal to 1 squared, y will be 1. If I put x equal to 2 squared will be 4. Let's put some negative numbers also. If x equal to minus 1 squared is also same as 1. Let's put minus 2 also. Minus 2 squared will give me minus into minus plus 2 into 2, 4. Let's see what happens if I put x equal to 0. When I put x equal to 0, 0 squared, y is also 0. So basically, based on this relationship, this agreement, we got this table created. Yeah. Somebody joined in between, that is Ria. Hello, Ria. So Ria, we are talking about quadratic equation, and we will look at different properties of quadratic equation. We'll look at how does the quadratic equation transform by playing around with some of the properties of it. Yeah. So we picked up the simplest form of a quadratic equation, y equal to x squared, and based on this relationship, we plotted this table. We just derived this table. Okay. Nothing magical, nothing fancy about it. That is what the worst teacher can do. Okay, all right. Let's keep the jokes apart. So some of you have been dealing with my dad jokes. This is just a continuation of that. Coming back to this one. So we have got these points, x and y values, different combinations. Let's try plotting it in a graph. When I have x0, y0, let's say this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. minus 1, minus 2, minus 3, minus 4. I'm stopping there. So I picked up first point 0, 0. So this is 1 point that is coming from this equation. Okay. Now 1 and 1. When x is 1, y is 1. So I'm essentially talking about this point. 2 and 4. When x is 2, y is 4. So x is 2, y is 4. I'm talking about this point. When x is minus 1, y is 1. Minus 1, y is 1. This is 1 point. When x is minus 2, y is 4. Minus 2, y is 4. So, if I have a quadratic equation, Ludovic, if I have a quadratic equation that plots this U-shaped thing, which is parabola. Yeah? Now, when you look at parabola, little carefully, okay? You see there is a lowest point. Yeah? That is called vertex. If somehow with some magical stuff, if we draw a parabola like this, I will not have lowest point, I will have a highest point. But that will still be called vertex. Yeah, so this is the first one property of a parabola. Now, if you look at it a little more carefully, you will see that in the parabola, if there is a vertical line that you can imagine that passes through the vertex, this is actually splitting the parabola into 2 points. So this is called the line of symmetry, which passes through the vertex and splits the parabola into 2 equal parts, 2 identical parts. And if you look at this part, which is nothing but a mirror image of other side. Yeah? Or if you look at this side, this is mirror image of this side. Is that okay so far? Everybody okay? So, every parabola that you think of, the vertex that I'm talking about, if you draw a vertical a line like this, which passes through the vertex, it splits the parabola into 2 parts, and this line is called the line of symmetry. Yeah? I see somebody also joined in between. That is.
No, I just rejoined.
Rejoined. Okay. Okay. So Davik is also here. Okay. So one thing is vertex, other thing is line of symmetry. Vertex could be a lowest point or a highest point depending on how your parabola is aligned on the coordinate plane. So far okay? Yasmita, Sahid, Riya, Ritika, Neil, Sara, everybody okay?
Yeah, okay.
Pranit okay? Tony okay? Now, see, this is a problem that you guys are all dealing with. Dealing with a teacher who claims to be the worst teacher and is very playful at this age. Even at the age of 49, he is very playful. And what I'm going to do is, what happens if I put a minus to this? Yeah, Pranit knows it. Okay, so without anybody noticing what Pranit did, what will happen if I put instead of my equation for the parabola being y equal to x squared, where we saw this as the parabola, if I put a minus to it, what happens? Anybody? Riya, Sahib, Davik, Dev, Jana, Neil, Sara, anybody? Saranya? Yes, Jana.
I think it'll go below like x equals 0, it's gonna be like opposite.
It flips upside down. That's what you're trying to say? Dev, is that your response too?
Yeah.
Okay. And we will quickly do that, okay? Let's quickly do it. Because it's just not about what Jana says, what Davik says, what Dev says, or what Pranit said silently. Pranit did a sign language. He said, you put a minus, it flips upside down. And that action was speaking the 1,000 words. Let's look at it. What's happening? When I put x equal to 0, y is also x squared, the 0 squared, minus 0 squared doesn't make a difference, it will be 0. When I put x equal to 1, it becomes 1 squared, but minus of that, so y will be minus 1. When I put x equal to 2, it becomes 2 squared, there is 4 but a minus to it, minus 4. When I put minus 2, again whole thing is here, minus 2 will be minus 4, minus 2 square will be 4 and then a minus to it. It still remains minus 4. When I put x equal to, let's say, minus 1, so minus 1 square will be 1 and minus to it, so y will be minus 1. See, every value of y is negative. If you try plotting it, 0, 0 is this point, same common point, 1 minus 1. So when mosquito is after you, beta, Tony, is mosquito chasing you? Same for you? Okay. So you guys can find out one of this. Yeah, I have put 2 extra machines there. Those blue ones that you see, that is also for, it radiates those what you call infrared wires actually, which keep the rodents away. So I put 2 of them. I have one here. Let me turn on this one also. Okay. Hope you guys feel a little better. Okay, so 0, 0 is this one. 1, x is 1, y is minus 1, x is 1, y is minus 1, x is 2, y is minus 4. It will be here. X is minus 2, y is minus 4. X is minus 2, y is minus 4 here. X is minus 1, y is 1 here. So what you are seeing is your parabola flipped upside down. So that's another takeaway. Meaning, if you have a parabola where the coefficient of x square is positive, here it's a 1. If it's positive, your parabola is facing upward. If your coefficient is negative, your parabola is facing downward. Is that okay so far? Everybody? And again, I did not say anything in air. Whatever I am claiming right now is what you guys saw here. Yep. Alright. So let's keep that as first takeaway from all the discussion we have had so far. Now we will try to bring some standards into what we have done. So, what is the standard form of a, okay, before I go there. So, we saw that any quality equation that we look at, that draws a parabola for us in a coordinate plane. Yeah? And if that is not working, you have to take more.
No, it just barely says itchy right there.
I'm sorry, Vita?
The mosquito barely says itchy right there.
Okay. Okay. So, we saw that any quality equation that we pick up and we use for drawing it on a coordinate plane, it draws a parabola. Now, parabola could be here, 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 here. Everything is a parabola, right? Anything which is a U shape or somewhat similar to a U shape is drawing a parabola for us. So, we just picked up one sample example and we looked at a quality equation, simplest form of quality equation, and we drew a parabola and we saw that if the coefficient of x squared is positive, my parabola is facing upward. If the coefficient was negative, it was facing downward. So that's the first takeaway. So any quadratic equation will draw a parabola for us. Is that okay? Yes, Smita, so far? Ria, okay?
Yeah, okay.
Yeah. So what is the standard form of a quadratic equation?
Ax squared plus bx plus c equals 0.
So my standard form of a quadratic equation is not mine, anybody's. Ax squared plus bx plus c equal to 0. So if I am trying to represent that in a coordinate plane, I will say y equals to ax squared plus bx plus c. This is my standard form of a quadratic equation. Now if we relate back to what we saw just a minute ago, that is the coefficient of x squared, which is a in the standard form. If that is a number greater than 0, my parabola is facing upward. If that is a negative number, meaning lesser than 0, my parabola is facing downward. So this is the first thing we have seen so far. Now let's play around a little bit more. If I say the equation that we looked at was y equal to x square. If I say y minus 3 equal to x square. So y equal to x square plots a parabola for us like this. Right? We saw that table. X, y, 0, 0, 1, 1, 2, 2. Minus 1 gives me a 1, minus 2 gives me a 4. Yeah? Now what I've done is, in the parent equation that we had, y equal to x square, I'm doing a minus 2. Lonania.
Sorry, I'm late.
No worries, beta. So we are talking about quadratic equation, and what does quadratic equation do when we plot that on a graph paper. So we just saw that if we have a quadratic equation that plots a parabola for us, and I'm not repeating that again. When we deal with that a little bit more, you'll be able to catch up. Otherwise, you have to anyways watch the video of the class for whatever you have missed. But here, the takeaway so far, Nanya, was that if I have a quadratic equation, the simplest form of quadratic equation y equal to x squared, it plots a parabola like this. And from that, what we have derived so far is, if my a, which is the coefficient of x squared, here in this parabola, in this equation, coefficient of x squared is 1. If my coefficient is positive, meaning it's greater than 0, my parabola faces upward. And I have not done anything magical, okay? I just took this equation, substituted some value of x and y, and found the corresponding value of y and plotted that, okay? And we saw that it faces upward. And then what we did was, what if I put a minus to it? If I put a minus to it, meaning my coefficient here is minus 1 for x squared. And then we saw that it flips the parabola upside down, so it became like this. Okay? Now I'm continuing with my game plan and playing more with it. What I'm doing now is, if I have had this equation for the parabola, I'm subtracting something from y, and I'm wanting to see what happens to my parabola. Anything that you remember, Puneet? What happens if I do a minus to the y?
You would shift up.
Mhm.
Because if you move across, that equals 3.
So instead of going for this equation, I went for this equation. Meaning I did a subtraction of minus 3. Let's do minus 2. Okay. Any be it minus 1, minus 2, doesn't matter. Okay. If I do a minus to the y, I want to see what happens to my parabola. Okay. Anybody who wants to make a guess what will happen if I do a minus here? Davik, Sahit, Jana. Yeah, Jana, go ahead.
Would the graph like shift
Which way?
right to?
Right?
It's either right to or down to.
Let's see. Now you are getting to realize why I claim that I'm the worst teacher. I don't remember. No, I'm just kidding. I remember, but I'm wanting you guys to see a more convincing view of what I'm saying. Okay, it's not about you guys memorizing everything that I say. Okay, so now my equation is this. Earlier my equation was y equal to x squared, and this is what we were plotting. I mean, these are the values that we got, and we plotted it, and this is what we got. What we'll do is, I'll put a coordinate plane right next to it. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. Okay? Now, let's see what happens to this equation. This is, for me, it is again a relationship between x and y, a contract between x and y. Yeah? You need one more, Amtar?
No, I don't.
You're fine. I mean, if you want to put something in your feet also, I have to give one. All right. So now let's see. When x is 0, what happens? X is 0. This became 0. So y minus 2 equal to 0. That means y equal to 2 goes to the other side, becomes 2. Y equal to 2. When x is 1, that is 1 squared and this y comes this minus 2 comes to this side becoming plus, so 1 plus 2, 3. When x is 2, this becomes 2 square, that is 4, and plus 2, 6. When x is minus 1, so minus 1 square will give me a 1 plus 2, that is 3. Minus 2, x equal to minus 2. Minus 2 will give me a plus 4, and then 2 goes to this side, becomes 6. Now look at this, 0, comma 2. When x is 0, y is 2. When x is 1, y is 3. When x is 2, 6, somewhere here. X is minus 1 is 3. X is minus 2, 6. What happened here? The parabola shifted by 2 points. Every point, the 0, 0 moved to 0, 2. 1, 1 moved to 1, 3. 2, 4. 2, 4 moved to 2, 4 here, moved to 2, 6. Everything is shifted by 2 points. What did we do? We did a minus to the y. As soon as you do a minus to the y, it shifts upward. And I'm not going to bother you guys by doing what happens when I do a plus. I leave it for you guys to practice. But what I'm telling you is, if I'm doing a minus, it moves upward. If I do a plus, it will move downward against this base. Okay? You can do the same thing. Put y plus 2 equal to x square and create this table and try plotting it. I mean, in a rough way. You will see that this guy moves by 2 points and starts from here. Okay? I'm just giving you guys a relatable concept. You can try this by yourself. So the other takeaway from this whole thing is, by understanding the property of a parabola is, if you are talking about a parabola or a quadratic equation, or equation for the parabola, which is a quadratic equation, first takeaway was, if my coefficient of x square is positive, it is facing upward. If my coefficient of x square is negative, it is facing downward, inverted U. Second thing we found was that if I do y minus this in this equation, when I do minus, it moves minus from y, moves it upward by that many points. Okay? Plus from y moves or shifts the whole parabola by that many points. Every point shifts down. Sahid, Samriddhi, Yasmita, Viswa, everybody with me so far? Riyak, Ananya, everybody clear? Yeah? Okay. Yeah, and guys, even if I say or don't say, the implicit agreement that we have among ourselves or between you, each one of you and me is, don't be shy when it comes to asking questions, okay? So we saw another dimension to it. Meaning, if you have a parabola, if you have an equation, quadratic equation, even let's say if I have equation like y equal to 2x squared plus 4x minus 7, okay? This plots a parabola, let's say somewhere here, because it's a positive, so I'm assuming that this is. If I do y minus 2 or y minus 3 or y minus 7 to the existing equation, I'll simply assume that I'm doing a minus 3. That means I'm making the parabola move upward. This whole thing shifts by that many points. Yeah? David with me? Sahit, everybody with me? Now, let's look at another interesting aspect. I hope I'm not making Praneeth sleep. Yeah? Okay. Now let me give you guys, so we have looked at two properties. Everybody is with me so far, right? Sarah, Neil, Uh, then Saranya, Vishal, Vishwa, everybody?
Yes, sir.
Okay, alright. Now, let's look at another situation. Y equal to x squared. I'm just picking up a sample equation such that you guys can relate it. Okay? Y equal to x squared and y equal to 2x squared. What will change? I have not subtracted from y. My coefficient is still positive, both the scenarios. What changes with the parabola? Okay. Any guesses? Any interesting guess? Any creative guess? I got one answer from Praneeth, and that answer is spot on. But I'll go back to Praneeth to explain that. But before I go to him, any other creative thought? What happens? What's the difference between this parabola and this parabola? Whatever we have learned so far is there is no minus, so y is same. So we're not talking about upward or downward movement. Both the coefficients are greater than 0, both are positive, so both are facing upward. But there is a difference between these two equations. So what's happening here? What is the change that you guys anticipate? Yes, Smita.
Does the y equals to 2x squared have more of a vertical stretch?
You are going the right direction, but can you describe that a little bit more? You said vertical stretch, okay? How do you describe that?
Stronger?
I'm sorry, Vito?
Just like a more stronger vertical stretch, so it's like the number's higher, it goes more inward, like.
Okay. I'm pretty sure you're thinking in the right direction. Let's hear what Dev wants to say. Yeah, Dev.
It's good you originally to be ours.
I'm sorry?
You called.
Yeah, I called you. I saw somebody that had raised hand. Was it Neil or was it Dave? I think Neil.
I think it was you.
Neil? Yeah, go ahead.
I think it will get wider, right? The parabola.
Which one will get wider? 2x will get wider or x will get wider? 2x will get wider? Okay. Now, this is the trap that we're talking about. You guys are trapped with a very less intelligent teacher. Let's look at both the scenarios, okay? So this is y equal to x squared and this is y equal to 2x squared. Let's look at the possible x and y values. Yeah, Praneeth, but you were trying to explain, yeah, what is happening here? You said, Praneeth told me this, okay? I asked Praneeth what is happening. He said this versus this. And that was a right answer, but I'm just trying to pitch your brain to describe this a little bit more.
So since your coefficient is a whole number, it's not less than, like, it's greater than 0, but it's less than 1. It's not like a fraction. You're basically grabbing your two ends and pulling it so it's narrower and longer. Like they said, it's the actual influence of vertical stretch. Basically, you're just making it narrower and longer. And then if you're...
In which case I'm making narrower?
Narrower when your coefficient is a whole number, and then when it's a rational number, it will compress, which will squeeze down and will spread wider.
Okay. So if I interpret that correctly, you're saying that when the coefficient is a smaller value, I'm talking about a wider stretch.
When it's
With a higher value, I'm talking about a narrower stretch.
when it's a whole number, it's a stretch. When it's a rational number, like 1/2.
But here in both the cases, I have whole numbers only.
Yeah, and then as you increase it, your amount of stretch increases.
You're stretching it. Okay. So that's what Yasmita also said, that when in this case you are doing a vertical stretch. But let me put that in the simplest possible form so that everybody can relate to it. Okay. So and see, this is like my magic wand. I don't have to put any intelligence to it. We are interpreting based on the basic concepts that we apply and see what happens. So in this case of y equal to x squared, when x is 0, y is 0, x is 1, y is 1, when x is 2, y is 4, when x is minus 1, y is 1. When x is minus 2, y is 4. In this case, when x is 0, y is of course 0. When x is 1, this became x squared, that's 1 into 2, y became 2. When x is 2, it became 2 squared, that is 4 times 2, 8. When x is minus 1, again minus 1 squared will give me a 1 into 2, that will be 2. When x is minus 2, this became 4 times 2, that is 8. Okay? Tony with me, beta, so far? So far, okay? Okay. Alright. And Tony, you remember what is meant by beta? Beta is like a child. Yeah. Okay. So if I say beta, I don't want to call you a different way versus Praneeth versus anybody else. So I'll this is first Hindi word that you have learned from me, apart from maths. Okay? Alright. So coming back to this one. Now you look at this table and this table. This is the table for y equal to 2x squared, this is y equal to x squared. And here you see that your y is increasing much faster than the x compared to this case. I mean, your y is increasing at a much faster rate in this scenario because you have a 2 squared. So when x was 1, it was 1 and here it became 2. When x became 2, here it was 4, it became 8. So meaning y is moving faster. Meaning that's the vertical stretch that you guys were talking about. But let's look at a pictorial view of it also. Let's say this is 1, minus 1, this is 1, 2, 3, 4, minus 2, minus 3. Okay. This I'll use a bigger unit this time, okay? So let's say this is 2, this is 4, this is 6, this is 8. Minus 2, minus 4, minus 6. When I'm looking at this one, y equal to x squared, 0, 0, this is the point, 1, 1, this is the point, 2, 4, this is the point, minus 1, 1, this is the point, minus 2, 4, this is the point. So this is my first parabola that I'm drawing by using y equal to x squared. Now let's go to this guy. When x is 0, 0, this, okay, I'll use a different color marker so that you guys can visibly see the difference between the two. Both have the same center here, the vertex is common. When x is 1, y equal to 2. It came here, and 2, it became 8. Minus 1 was here 2. When minus 2, this was 8. This is the vertical stretch that you guys were relating to, correct? That means, see, it's about how do we kind of conceptually put it. When your coefficient of x squared is less, your y is moving slowly. Y is growing slowly. When the coefficient is getting bigger, meaning your y is moving faster. So every increase of x is making the y move much faster. And that's what you are seeing. In case of 2, it was here, but in this case, it went here. So you actually vertically stretched it. So it's like you are holding on to this parabola and pulled it down, and this became thinner and taller. That's what you are seeing. So that's the vertical stretch you were talking about, Yasmita, correct?
Yeah, that's what I was talking about.
Yeah. So the problem that I was facing was that I was thinking that how do I relate it? Now when I have a pictorial or intuitive representation of that one, that makes it easy for me to follow. So you guys were not wrong with what you said. I just put a, what do you call, a picture to the word. Yeah? Does it make sense? So tomorrow if somebody says, I will make y equal to 6x squared, I'll make y equal to 6x squared, I'm essentially talking about y moving much faster and this becoming much thinner. Yeah? And taller. Make sense? Is that my picture? Less hair on the head? I'm saying that my picture with less hair on the head. Alright. So coming back to this one, whenever you increase the coefficient, you are making your parabola thinner and taller. Yeah? If somebody says y equal to x to the power 8, you are making it wider and shorter. Yep? Yep? What is that called?
Compression.
Compression. Yeah, you are compressing a parabola and making it wider and shorter. Yep? Is everybody with me so far? Ananya, Jina, Dev, Vishwa, Sara, Neil, everybody? Was this concept relatable, easy to digest, Davik, Sahit, everybody with me? Okay. See, I am talking in the era of Facebook, where every post that you see on Facebook, you have to put a like, you have to comment. Since you guys don't comment much, so at least I'm bothering you guys to like. Yeah? Okay. Bad joke. Let's move on. So what we saw was, if you increase the coefficient, increase A, you are making it thinner. Thinner and taller. When you decrease A, you are making wider and shorter. Is that okay so far? So with 2 levels of protection, 3 levels of protection actually. This machine, that machine, and then wristband is still not working. So I am left with only one choice now. That is buying a mosquito repellent cream and keep in the class, so that when everybody comes to the classroom, first thing you will do is go rub it on your exposed area of the body, and then we'll get started. Okay. I don't want anybody to get distracted even by a mosquito. Okay. Alright. So far everybody okay? These are the 3 takeaways that we have looked at from a parabola and the property of a parabola. Yeah? Everybody believes in what I claimed just now? Okay, let's move on. Now, we looked at y equal to x squared to begin with. Then we said, okay, if I put a minus to it, it moves it upward. If I put a plus to it, it will move it downward. This was one thing we saw. Second thing we saw was, if my coefficient is positive, my parabola is facing upward. If I put a negative to it, it flips upside down. Okay. Then we saw, if we keep this and multiply it by something, I'm making my parabola get thinner and that much taller. Meaning, if I divide by something, I'm making it wider and shorter. Yep. Now, this is not enough. What do I mean by that? This is not enough. Meaning we have more opportunity to play with it. See, it's about we being curious, we being innovative, or what you call, more, there's a word which I'm forgetting, more investigative in nature. Okay? Meaning, if I have y equal to x squared, we have seen three different flavors of it by playing with it. Okay, if I put x minus 3, why 3 always? Today is the 5th day of the month. Let me put 5. Now what will happen? So I had an equation y equal to x squared. What I did was, instead of x, I did a x minus 5. And what will happen to our parabola now? Any guesses? See, this is the parabola that we had. This is the equation for the parabola we had, and which we drew, and we saw that this faces upward because it's a positive coefficient, and it does like this. Yes, Jenna?
Would our graph shift to right 5 units?
Right by 5 units, okay? Do you agree? So you are putting a minus you're saying that will move right. Because when we were doing a minus here, we saw it moving upward. Yeah, so here you're saying this will move right. Correct? And anybody in the class who wants to contest against what Jenna and Pranith are claiming? And it's okay. It's okay to have a very healthy argument. No? You guys don't like fighting with friends for a right reason? Okay, let's argue mathematically, okay? We'll not do any physical fight or argument. We'll argue mathematically. So this was our 1, 2, 3, whatever. Okay? Or let me not do that. Let me not do that. Let me do it in a more relatable, trustworthy way. So far nobody is tired, right? Of this boring speech? Tony? Did I get you tired, beta? No? Okay, good. So, these are the two equations that we are talking about. Let's look at the table for this guy. And I have kind of memorized this table now. 0, 0, 1, 1, 2, 4, minus 1, 1, minus 2, 4. I mean, this is coming from this equation. Nothing new. I'm not doing it one more time so that otherwise you guys will say such a boring teacher I'm dealing with. So I will try to avoid that boredom. Let's go. So now let's look at what happens to this table when I'm looking at this equation. Let's say when x is 0, this is 0, then y is 0 minus 5. Y is 25. I'm just thinking that shall I pick up a smaller number? Let's pick a smaller number, otherwise drawing this thing will look clumsy on the board. So 0 minus 1 is minus 1, square will be 1. When x is 1, this became 0. 1 minus 1 is 0, 0 square is 0. When x is 2, 2 minus 1 is 1, square, that is 1. When x is minus 1, so minus 1 and minus 1 became minus 2, square will be 4. When x is minus 2, it became minus 2 and minus 1, minus 3 square, that is 9. So earlier our graph was minus 1, 1, 2, 3, 4, minus 2, minus 3, minus 4, 2, 4. I'm using bigger units, okay, so that we can deal with this. And this is for minus 1, minus 2, minus 3, 1, 2, 3, 2, 4, 6, 8, 10, minus, okay. Now 0 is 1. When x is 0, y is 1. When x is 0, y is 1. Okay, this one. When x is 1, y is 0, meaning we're talking about the x-axis. When x is 2, y is again 1. So 1 is somewhere here in the middle. When x is minus 1, y is 4. When x is minus 2, then x is 9. Here. Okay. So what did you see between this guy? Okay, there's nothing to see. It's an imaginary parabola that you guys have been forced to believe in. 1 is here, 2 4 is here, minus 1 1 is here, minus 2 minus 2 4 is here. Your parabola was here. You put a minus to the x part of it, and what you saw was a minus 1 moved it by 1 unit. So your center, the vertex was at 0 0, it moved to 1 0. You literally shifted it by 1 point. The whole parabola from here, look at the center of it, the vertex, which was at 0 0, now it is at 1 0, 1 comma 0. If you would have put this, you would have seen this moving much faster and coming to starting from here kind of thing. So a negative here gets your parabola moved by that many points on the right. If you put a plus here, you will see the same thing happening in this direction. Yeah. So I see some of the kids from the next batch have already joined, and let me see who are those poor kids who are wanting to break their head with what we are doing right now. Okay. There's nobody from the next class. That is good. Because if those younger ones, okay, no, I think it's Bhuvi has joined. So Bhuvi, you can join after 8 minutes, but okay, otherwise you'll hear something that will look very cryptic to you. And I think Noah is also there. So Noah and Bhuvi, you guys can join after 6-7 minutes. Then you will hear something which will make more sense to you guys, okay?
Okay.
Yeah. So what we are seeing here is another property or the behavior that we just noticed, that if we have x, something being subtracted from this x in this quadratic equation, it moves your parabola to the right. If something is added to the x in the quadratic equation, it moves your parabola to the left. So that adds to our kitty of understanding of properties by 2 more points. What you are seeing is, Rudraksh, you are here but you are not here. Sit down without making even any sound. In English that is called pin drop silence. Alright. So we saw another property getting added to our understanding, that is, if I do x minus, let's say h, moving to the right by h. If I do x plus h in the quadratic equation, here, when I'm talking about x plus h, I'm essentially talking about x plus h here, this part, okay? I'm not talking about this or this, yeah? So, when I do x plus h, I'm talking about moving to the left by x points. And you can always take your vertex as a reference and see how the whole thing is moving. Yeah? Is that something that makes sense to everybody here? Sarah, Neil, Yasmita, Saranya, Viswa, Jana, Tony. Is that print of silence? Yeah. Okay. Nanya, Dev, Vishal. Now, let me add some more color to it. So far, I have been saying that we are learning the properties of it. If I give you guys a quadratic equation, when you draw it on a coordinate plane, it draws a parabola for us. Yeah? So, any quadratic equation. Now I am being little greedy. If I say 3x squared plus 6x minus 9 is my quadratic equation, this will also draw a parabola. And this parabola will be facing upward or downward? Yeah? Up. Because you are looking at only the coefficient of x squared, which is a positive number. Okay? So this is going to face upward. Okay? Let's say it's drawing something here. Okay? Or let's say this one draws something like this. Can somebody tell me how would you find out the intercepts of this parabola? Yeah.
There's 3 ways. You could do the map it to one of the standard formulas, or you could do A times C, split the middle number, or you could do the...
I would want you to go one step back. backward actually. So I'm saying, how do you find the intercepts of this parabola? So first starting point for you would be that okay, we could have y-intercepts or we could have x-intercepts. Yeah? When it will have y-intercepts, meaning where the y value will be 0. So what I will do is, I'll make y equal to 0 and solve for this equation. That will give me y-intercepts by solving these two. So these are the two values of x where it is touching the x-axis. Similarly, there could be a y-intercept also, meaning where my y-intercept, meaning the point where the parabola touches the y-axis. If it does, then on those points my x value will be 0. So I'll put a 0 for the x, this becomes 0, this becomes 0. So y equal to minus 9. Just by looking at this, we can say that okay, when the value of y is minus 9, meaning somewhere here, it is touching the y-axis. So whatever I drew here, that is as good as being useless. I did not draw it properly. Yeah. So how you will solve it? That we can always figure out. We'll talk about that. Sit in the last row, as if you are not here yet, because your class has not started yet. We are still dealing with the elder ones. We are talking about parabolas. Okay. So coming back to this one, I'm saying if I have an equation, if I have a quadratic equation, that will draw a parabola for us. And by looking at the equation, by dealing with the equation, we can figure out where it could touch the y-axis, meaning what is the y-intercept, where all it can touch the x-axis, meaning what will be the x-intercept. It might so happen that we are drawing a parabola. You have an equation which you use for drawing a parabola, and this draws like this, meaning it's not touching the x-axis. That means there is no value of y, there is no value of x for which y is equal to 0. Right? So we will relate those concepts and we'll deal with some problems. Today what we did was, we just looked at all the possible properties of a parabola to relate to how does the parabola transform depending on what kind of changes we could do to it. By looking at different values, how do we interpret the positioning of the parabola, how does it move and all. Okay? And in the next class, what we'll do is, we'll pick some problems, we'll look at how do we solve those problems to derive the other properties, meaning x and y intercepts. Or, so far I have just talked about vertex, but we have not talked about how do you find out the coordinates of the vertex. We don't know. We have not explored that yet. So we'll look at those concepts and practice few more problems in the next class. What I will do is, I will still recommend you guys to go to Khan Academy and try doing the unit test in Khan Academy. Okay? I think it's in advanced math, advanced level, which is unit 12 probably. And then there's a unit for, there's a lesson for parabola. Try doing the unit test by yourself for now. And rest of the problems, we'll solve few problems in the next class and see how we are able to apply the concept that we have learned just now. Okay? Any questions before I let you guys go?